Okay, I think we are online. I'm going to start as well on the.
The waiting room.
Yeah, just.
Hello, hello.
Hello
Can you hear
there.
me? Dr. Abbasi.
Hello?
Hi, can you hear me? Can you hear me?
Hmm.
Can you hear me yet?
Oh, cool. Wait a second.
How about now? Can you hear me or see me?
So what's
There's
going on?
something. I'll put off Zoom.
Can you hear me? Can you hear me?
Hello?
Hello, can you hear me?
Are you able to hear us? What's going on? Okay, let's see here.
Just test speakers and microphone. No.
Same system. Hello?
Hi, can you hear me?
Oh yeah, now we do hear you.
Now we are ready to rock. Great.
No, we are already online, and today I'm going to introduce us, and because Amanda is not going to be here for AI conversation, I think so this is Dr. Abbasi. Welcome to Essence of Science. What is AI and how it's going to improve medicine? I'm Dr. Abbasi for Essence.
This is Misha. I'm Jimmy.
And Misha and Jimmy are AI experts, and we have a special guest today, Dr. Ashley Mack from California. Ashley, why don't you introduce yourself?
Absolutely. Well, thank you so much for having me here. So my name is Dr. Ashley Mack. I am a physical therapist. I've been practicing for over 10 years. And my specialty is actually helping folks live free from back pain and sciatica. So from a physical therapy and movement standpoint, as compared to the deep medical and interventional standpoint of what you do, Dr. Abbasi. So I really appreciate everything that you do. And I got really interested in looking into the AI sphere because about a week ago or so, you and I had the opportunity to talk about the procedures that you do and how the amount of people going through back pain and sciatica just from that specific region itself, there's so many people, so it ends up being more of not just a health issue, but a public health issue. And so it got me thinking about how can we help these people more? Because ultimately, there's only so many clinicians out there. There's only so many physicians and surgeons such as yourself. There's only so many PTs like myself. And truth be told, we also discussed that there wasn't really a standard of care, which makes it very, very challenging when it comes to trying to fix a problem at scale, especially something that is as common as low back pain and sciatica.
Yeah. And you know, today conversation is about AI, artificial intelligence. And I like to do a little, digging into this, for us to understand how AI can help us, we have to understand what AI is. And to understand what artificial intelligence is, we have to talk a little about biological intelligence, what that really is, because these are continuous conversation. Talking about biological intelligence, obviously, we human, we think we are intelligent. And the proof of that is all the technology that we are using today to have this podcast. We have built these marvelous technologies, these models, these ideas, and that we are utilizing the laws of physics to enable us to solve problems that would be even 50 years ago like magic. What is intelligence? Let's a little talk about, go around the table. What do we think what intelligence is? Ashley, you want to tell us, what you understand under intelligence?
Yeah, so the way I see it is that intelligence itself is being able to take the facts and information and create something out of it or do a specific action. And I like to relate intelligence to a lot of various different things. You have emotional intelligence, they call it EQ. you have the intellectual intelligence, which is going to be the IQ. And so you have these opportunities where you can gather the specific information and do something about it or have a specific action. And so, especially when it comes to the IQ, it's knowledge, the ability to gather information and create a specific decision. Emotional intelligence is the ability to actually sense someone else's emotional state and react appropriately so you can get whatever reaction it is. So I think from itself is the ability to actually gather data, information to elicit some sort of action.
And that is a very good description, but I want you guys as well comment on that. Now, just in a common sense, so for somebody who's not in medicine, when you hear intelligent, each of you please comment. What do you understand under intelligence?
So first of all, Dr. Mack, I believe some like more in-depth introduction is due. My name's Misha. I did my undergrad in statistics and my master's in artificial intelligence from U Chicago. And Jimmy, would you like?
Jimmy, I did my undergrad in Johns Hopkins, focusing on information system.
So to go back to the question, the biological intelligence, I would say it's a living organism's ability to observe and classify or learn from past experience to make future judgments.
For me, I think beyond what Misha said, I think creativity is also an important part that shows the intelligence.
Absolutely.
Just how human create so many like methods, curing disease, create technology. These are all.
And that is exactly the difference between the intelligence and memory, because you can have a database that if you have A, B, and C, then do 1. If you have A and B, then do 2, and so on. It is practically that would be a table of content that that is programming. But imagine you have certain number of information and you combine them in a way that has never existed before. Based on historical information, you create solution for problems that you have never encountered before. Combining the information and providing solution, then that is what the advantage of living being. We are not necessarily programmed for every possibility, but we do something what we call heuristic. Based on the information that we have, we come up with a solution that we think going to work best. And surprisingly, most of the time, it works. And so it's not memory. It's not about knowing all the content of a dictionary and then based on some little table of content behaving. Now, for a long time, we thought that is only limited to human. We now know better that intelligence has many, many layers, many, many levels. Like as Ashley was mentioning, that emotional intelligence, that was we're blind to that for a long time. We just understanding, being able to read other people's emotions and react, have the best reaction to that, is what makes a human human. And the machines are really not good at that yet. But when we get to that, that might be changing based on the advances that we have made now. So this is the human intelligence, and it has something to do with how our brain works, right? Ashley, I want you to comment on that. I'm sure you have all those things about. Educate us a little about what you're understanding about how our brain, how our neuron work in our brain. Because we don't have like a transistor that is yes and no, right? What do you understand how our brain processes at the neuronal level information?
Yeah, absolutely. I think, it goes back into what it was like even 5 to 6, maybe even 1,000 years ago, where before the evolution of all this technology, the focus on what our cells and what our brains were doing was to just make sure that we survive, that we do not get killed by the elements, and so that we are able to actually meet the needs, our ability to find food, shelter, and also a community to make sure that we are not on our own, right? And so over the years, over the centuries and generations, our ability to So our neurons end up, I guess, evolving and giving us an opportunity to really process this information so we can actually solve these problems a little bit faster. But it's all really based on the fact that we did have these memories in the past where the first priority was survival. But then from there, we transition into the other needs and the other problems that come about because of the fact that we no longer have to worry about, are we going to get eaten by the saber-toothed tiger, today. We can focus on the other things, building a community, and also even being more aware of the processes that happens in our body, whether it be to pain management or managing even the disease itself.
Yeah, and that's a very good description that obviously evolution selected us to have more and more problem-solving solutions, especially because we are a social animal. We have this communication that's make us the language. A big part of our intelligence is related to language. And when we come back to that artificial intelligence, you guys are going to explain how that artificial intelligence works at the language level. It's a language model, more or less. But coming back to the neuronal level, now our neurons, obviously we have action potential or not. And that level, it appears to be a digital thing, action potential or not. A neuron either shoots action potential or not. Can you stop that? But when you come back to that,
Grab the phone.
just stop it, that's fine.
You want it?
No,
You don't want
let's put it back.
it? Okay.
Just put it back, yeah. But the way this the action potential is produced is not a one-to-one, that if you have one signal goes to the neuron, it shoots automatically output. That process is very fuzzy. Each of our axons, each of our neurons have hundreds of thousands of connections, and it is practically something that was described as fuzzy logic, meaning that it is not a yes or no, it is a lots of different stages between, and this medium has produced whatever we are. As a matter of fact, you would be surprised or scared to understand how little our short-time memory is, how inefficient actually our processing is. But because it is so maximized on using different pathways, becomes so powerful because our information is not based on yes or no. If you would have same amount of, connection transistor like our brain has, it would be very, very minimal computing processing machine. But because each neuron doesn't have a yes or no, but thousands of levels between, that becomes extremely powerful, a little bit like a quantum computing, not quiet, but in that direction. Now, based on those models, we, for a long time, since 1970s, we have been creating computer models that are able to simulate our brain. We have a name for that. You guys know what it's called?
Neural network.
Neural networks, yes. But that's a very good question. How can a digital system create a neuronal network? And it comes back to Turing's universal machine. In the Turing universal machine is that a simple system that can process only yes or no, with proper programming, can simulate anything that you can imagine by just repeating the processes. And we are not going to go on the bottom of the neural, how Turing universal machine works, but more or less it says that you can, on a digital system, simulate anything you can. And the proof of that is that we can today create intelligence system based on a system that understands only yes and no. To my best knowledge, we don't have anything that on the computer system as of today. Those quantum computings are coming to existence, but they are extremely rudimentary. Everything that we work is based on a digital system that understands yes or no. And we have been quite successful to create these neuronal networks and they create this kind of intelligence that is not only based on yes and no, based on Turing universal theories. Now we are going to step into a domain of YouTube.
Oh, well, before we go to that domain, can I ask you a question?
Yes,
or
please.
Can I ask the medical professionals a
Yeah.
question regarding human neurons? So, Ashley, you just talked about like how evolution played a part in how our neurons are activated. So I want to ask each of your opinion on what do you think matters more to our development? Is it whether it's something hereditary in our evolution or something we learn? Like, we have a natural aversion toward food that looks blue or greenish because they're moldy, and we associate our ancestors, some very unlucky people, associate that with illness and disease. And we have a natural tendency for food that appears to be more calorie dense and more fat and more sugar. So do you think that played a more important role, or learning part plays more important role?
Ashley, please go ahead, take the first shot at it.
I think it's a fantastic question in regards to like what was more important, but I think the really big underlying thing, it's not necessarily whether one is more important than the other, because they actually do need to both exist in order for us to survive. I think one of the coolest breakthroughs that us humans go through is the fact that we learn through accidents. And those accidents can actually result in some really amazing discoveries. So say, for example, like penicillin, for example, right? Penicillin was found, from I think it was a bacterial mold. And because of that, it was an accident, right? It was the same thing, like the most delicious cheeses come from the fact that someone actually happened to leave their cheese in the cave, and they're like, oh, I shouldn't eat this. But you know what? Let me try this out. Oh my gosh, it's the best cheese ever. Right. So I wish I could say one is more important than the other, but I don't think that we would be alive if it was for one or the other.
No, that's a very good statement. And let me put it this way. There are processes that are important for life and death. Like if you eat something that had certain material, you'll die. You will not reproduce. So the nature, the evolution has created like an animal in their natural habitat. They would never eat something that would be deadly to them. Like there are certain things that are toxic to horses, right? Yep. The horse naturally knows avoiding those plants. They go and eat around them for a simple reason. Those horses that didn't follow that, they died, didn't reproduce, and they were self-selected. Now, it goes something beyond that, though. Now, that is a natural selection at the level of your neuron cooperate together. You develop on the instinctual level aversion or affinity for something that's good or bad for you. And then you survive. But now, imagine now that the taste of bitter, we don't like taste of bitter, but eventually we learn to like coffee or chocolate or things like that, even though they are naturally bitter, because we learn, like children don't like coffee, but adults do. It is something that we can then overcome certain network in us, that in our brain, that thinks that we overcome those instincts, but that is a learned process. That is something that we come and the combination as well. You know, nobody really drinks coffee directly. Coffee is not made. We have to go through a process to make that whatever it is to a coffee. And now we know many of them has positive effect on us. Like coffee keep me most of the days awake for me to go through my day. I couldn't function without coffee. But did I like the taste of coffee many years ago? No, I didn't. But you see, this is, as Ashley said, this is a combined effort between, there is a part of our intelligence that is, it's like instinctive. But for us humans especially, there's a part of our intelligence that is like an empty machine. It's waiting for information to process it later. So it's a combined process.
Understandable. So in the AI analogy, maybe a hyperparameter and a parameter, right? The hyperparameter decide the rate at which the neural network learns the pattern, and like how many layers of neuron are like the weights of them, like, or are there other restrictive or like exceptions to the learning process?
So this is
Okay.
already way above my
Okay.
head. So why don't you go and you two take over
Yeah, of
and
course.
explain to us, first of all, the origin of the artificial intelligence, and please talk as well about the models and make it in a way that, you know, people who don't come from your side understand what those mechanisms, what those models are, and how artificial intelligence work.
Hey, would you like to say something?
Yes, just based on what we discussed, the model itself is something empty. So it starts with nothing in it, and we feed the model with information. For example, our experience, our past data, we pass into our model. It gives us a result. At first, it might be very wrong, but we can tell the model the result is very wrong.
Is the model language based, or how is that model based?
So initially, the model is not language based
It
because
is not.
language is very hard. So initially, it can only, for example, be used to differentiate pictures, differentiate things. But it is lately that we discover a way to make it work on language model. So the way language model works is it look at some words before the word it want to compel, and it generate a list of words that's likely to come up, and then it choose the most likely word.
Yeah, that's a little advanced.
Yes.
Yeah.
But the main concept is it read over a lot of paragraph and learn to see what words should come after another word.
So it is a statistical model that looks for association between words without really understanding what those words are. But let me tell you, when I'm a child, many of those words I hear, I don't understand them. But once I associate it, so it is pretty much like a child who learns any language, right? So please explain that model a little more.
Yeah, language itself, it's very advanced. Maybe we can step back a little bit and like take the most generic form of neural network. So let me give you an example. If we want a model or a mechanism, actually it's purely computational. Actually, it has a closed form solution. Let's say an algorithm to distinguish a digit in a 24 by 24 724 pixel square. Like, how do you write a number, and how do you have an algorithm to distinguish what the digits are? So the way it works is that you have multiple layers to detect multiple patterns. So if on this pixel the grayscale light up a bit, is either pure white or pure black, or somewhere in between, a grayish area, and certain pattern got triggered. We don't fully understand why or how they behave, but an analogy would be, if you see a circle-ish thing, then you can see that might be a 6 or that might be an 8, but that's probably, or that might be a 9, but that's probably not a 7 or not a 2, or maybe there's a 2 because there's a curvature, so you identify a curvature, but that might not be a 1 because it's not a stick. So through trial and error, so called forward propagation and backward propagation and multiple times of training, the AI has a confidence score in like the probability associated with the correct answer. If you give it 1 stick, then it's like 90% it's a 1, or maybe like 7% it's a 7, but maybe like 0.01% chance it's going to be classified as an 8.
But do you see how fantastically that's similar how children learn? Like when we are child, Ashley, you correct me if I'm wrong, but we use words the wrong way, and our parents correct us, say, no, but that's not what it means. You know, it is, you're wrong about that. And then they correct us. They hones us about toward what that language means. Like, even as a foreigner, when I was here and I was using a lots of words, and still do, the wrong way. I use a word that, for example, Amanda tell me, but that's not what it means, what you think it means, and so on. And then correct me and hones me toward the thing. Now, Ashley, did you grow up in the United States?
I did, yeah.
Did you grow bilingual or just with English?
Just with English, but I like to say I'm really good at ordering in Chinese when I'm at restaurants. That's kind of like conversational restaurant Chinese is what I got. And so, but I think one of the really, to kind of piggyback off of what you're talking about, I think one of the biggest things, like especially with human learning and also this artificial intelligence, is this feedback mechanism, right? The feedback mechanism to be able to say, okay, these are the probabilities, but this is the information that I'm getting back, confirming or refuting what I or the system was thinking. And yes. And if I may just share a story with you. I remember early on in my career, one of the big things was especially like transitioning to business ownership. There was someone that I knew and they said, all right, well, what we got to do is we have to do sales, marketing, deliver our service, but we need to develop a system. And I had no idea what a system was. I said, I wanted to make sure that I fit in. So I was like, yeah, we got to build a system. But the entire time I had no idea what they were talking about. And in essence, the system itself is a series of processes that allows us to have consistency. But in order for us to realize and understand that the system itself was working, whatever process we were working, we had to get that feedback loop. We had to be able to say, how can we tell if this was a success or this wasn't? And so from there, that's where it really started to click together in regards to just trying to understand even just the concept of human intelligence, or even, something as new. I mean, it's been around, artificial intelligence, for a while, but it's really interesting to be able to just put them all together, especially the feedback, the context, what the scenario is.
Yeah. Now, that is very interesting, though. Now, with the chat GPT, we know artificial intelligence model has existed for a while, but only in the last year or two, that is now we are going to a place that it has truly practical usage. Now, from the model you two just described, how do we get from that model to chat GPT or other models? Now, first of all, first question, how do we get from what you described to the artificial intelligence? Number one, that's question. Number two question, what are those models? Because we know OpenAI or ChatGPT is just one of those models. Educate us a little about, these two processes.
Okay, so to sort of go back into like how AI learns things, how human learn things is by instruction. It's like when you use a word wrong, your parents or your friend tell you that's not how you use it. So the way AI works is that there's a loss function. A loss function means the difference between the desired output and what actually got outputted. So if you have the loss function and you try to tweak every variable, I mean, one variable is the weight of the neuron. That's like the basic unit of a neural network. Every weight of the neuron and how they interact with other neurons are all the variables that are associated with this loss function. So this loss function, a very simple one, can have like around 20,000 variables. So you are solving a gradient descent problem with 20,000 variables. You're like in a 20,000 dimension space, and you try to find the line of fastest descent.
And that sort of explains why we are now there to be able to, in real time, to make those computations. Because we understand as human 3-dimension, right?
Yeah.
Now you're jumping to 20,000 dimension. Yeah, you can imagine the calculation there is astronomical, and our models are now getting to the place that our computational power is enough to do calculation like that.
So Ashley, are you familiar with gradient descent?
I am not. Fill me in with that.
So let's have a 3-dimensional example. Suppose you're on a peak of a mountain and you're trying to get to ground level really, really quickly. Then you have to ask yourself, which direction should I go right now? Should I go to the x-axis, y-axis, or z-axis? Same way, gradient descent are used by a lot of creatures like mosquitoes. Mosquitoes actually detect human by detecting the most concentrated source of carbon dioxide. So the mosquito itself calculates which direction I should fly to get to the source really, really quickly. So imagine that in the 3-dimensional space, and you take that to 20,000 dimension space. And the same idea applies, though we are limited by our nature that we cannot comprehend them, but that's how computationally it works.
Mathematics of that works, we know that.
Yeah, it's true.
And the and the computational thing, it just, the amount of the computation is enormous.
Yeah, it used to be, but we have a lot of computation power right now.
That is exactly the point, that now we can have actual usage of that. I still want to know what other models are there before we go and talk about how is it going to help us in medicine? How is what you guys are doing going to help Ashley and I in our daily life and work?
So the actual output of artificial intelligence, most likely it's two things, either a numerical value or a probability. In the case of a numerical value, you're trying to predict something, like you want to predict the height of this kid based on some data, or you want to predict the market price of something based on historical data. So that's one thing. And the other thing is you predict a probability. The probability can be either a binary thing, like yes or no. Does this patient has this condition? The probability of this patient have this condition is like 90% based on the AI's result, or like 10% or something. And expand that use case, expand the options, maybe expand it to 10, like you're having a number digit recognizer, and what's the probability of this digit being a 1 versus being an 8, but all of them add up to 100%. And in the case of natural language, you are predicting the probability of the next word, or actually it's called token in natural language processing field. So imagine how many words there are in English. That's the number of distinct probabilities an AI gives when it's making the next prediction. So let's say something like, I want to drink water. Like you say, I want to drink. Every word has been tokenized into a vector. And the probability of generating the next vector being water, it's probably very high than a mouse or a microphone. Like I want to
drink a microphone.
The probability of the next word being a microphone is close to 0.
How does computer know that probability is high or low? How does that model consider from lots of previous experience, from lots of, or how does it calculate that I'm not going to drink a microphone?
So initially, for the computer, it's all the same. A microphone, a mouse, or a water, it's all the same for computer.
I want to drink TV. It's equally as possible as I want to drink oil or cell phone or anything, or Shakespeare.
Yes.
Well, Ashley, any interest to drink Shakespeare?
Sure, sounds like a great cocktail.
But during the process of computer learning, whenever the computer generates, I want to drink a TV, it got, like Misha just introduced, it got punished. So we tell the computer it is wrong. So the computer go back.
How do we punish the computer? I really sometimes want to punish my computer. How do we punish a computer?
So it's called punish, but actually the loss function Misha just mentioned. So we tell computer how wrong it is. For example, you want to drink snow and you want to drink TV. It's a very different. Maybe you want to drink snow might be 70% likely
less severe.
Does the computer get embarrassed, like when a child or foreigners use a word the wrong way and the people start chuckling and laughing and say, oh, I did something wrong? Does the computer get embarrassed?
I don't think so, because there are too many tokens for computer to run. It will be too embarrassed if you do it each time.
Maybe that's why it's more efficient than a human to learn.
Yes, probably, yes.
Okay.
But
so eventually it learns that it's a statistical possibility that water is much, much better than a microphone.
Yes, it generates that water is the most likely good word for the next token. So we generate, I want to drink water.
And also when you're dealing with words, the first thing you do is you uniform them to some degree. Like you do some stemming, like the word I eat, I'm eating, eat, eating, ate, something like that will be stemmed into like eat. And every word will be tokenized into a vector with numerical values. And you can have something like a king minus man is approximately queen. So
Mhm.
the numerical value of king minus the numerical vector value of man, it's approximately the numerical value of the word
That is
queen.
very interesting because I know in hieroglyphs, like an old Egyptian language, hieroglyphs,
Oh, okay.
and as well, I know in Chinese language, those signs that that they have something in common, that you combine two things that are each of them has a meaning, but combining them together give like exactly what you said, like a king and a woman gives you a queen.
King minus woman equals queen.
Yeah.
King minus man equals queen. So you're
Or
taking man
that
out
is
of it.
that is sometimes like that, or sometimes like a water plus the air makes rain, or there are many variation of that.
Or vapor, yeah.
Yeah.
Yeah, something like that. But that's the good mentality.
Yeah.
to go.
Yeah.
How words are created, some Chinese words are created.
Yeah.
I
Now,
think what's oh sorry, may I interject real quick? Because this is
Absolutely.
where you're bringing up something really interesting, but in a way, like for us humans, I know for myself, I have to make the same mistake like a couple times in order for me to like truly learn that mistake. And it seems, I mean, from artificial intelligence, like these neural networks, like because you have those values, you have those probabilities, perhaps it allows these computers and these programs to actually learn a little bit faster than a human, right? Like I know when I was a child, I had to burn my finger on the cigarette lighter 3 or 4 times before I realized I shouldn't touch that, right? And so I was making a note because in essence, what you're creating with these probabilities and the contextuals and the feedback mechanisms, you're pretty much in essence creating generations and generations of learning within the lifespan of within the lifespan of an average human. Which is amazing, and also probably going to save a lot of lives, right? If we go through enough trials of a specific incident, like instead of having 1,000 people eat this one specific mushroom, and then we finally learn that that's an issue, we can use this model to say, okay, don't eat this mushroom based on these simulated trials.
and I think the beauty of that is this learning process. Yes, our parents teach us things and so on and so forth, but it is not a one-to-one transfer. But these models, once you develop them, you can just copy them. You can just copy it from one computer to another, and everything that the first model has learned, you can make correct me if I'm wrong, you can take that model, put it on another computer, and then you have an instant of that moment that you copied that on another computer, and then each model can learn for itself, move in different direction. Is that correct?
Yes, that is correct.
So wouldn't that be like almost like the science fiction thing, that all of a sudden I make a copy of you, Ashley, and then you are the same until the moment I copy you, but at that moment you're two different people, and your experience and learning process just goes in a different way.
Yeah.
Now, those models, everybody knows ChatGPT. Talk us about other artificial intelligence model. What is the advantage of one versus another? Because we know Amazon has its own, Google has its own, Microsoft has its own. Tell us about those models. How are they similar? How are they different? Tell me a little about that.
So the mainstream models that we hear about these days, like they are all generating probabilities. Like Midjourney, have you heard of Midjourney before?
I haven't.
Like it create pictures. So like ChatGPT generating the probability of the next word or token, Midjourney generates the probability of the next pixel, the color of the pixel, the RGB values of the pixel. So and other models like you can have animation AI models.
They are concentrating on one kind of concept. Like one is the words and language, the other one is graphic, the other one might be just a calculation of like a chance of something to happen, or mathematical model. So, but everybody knows about ChatGPT because you write something and it gives you an answer. So you're telling me there are lots of other models there that they are not language based.
Yeah, language is just one of those
One
models.
of them.
One of the most useful.
Most useful to human, yeah.
Yes, because I think AI is so like popular lately. It's
Mhm.
because ChatGPT make more people know about it. It's
Make it
so
more
easy.
accessible,
Yeah,
yeah.
it's more easy for a lot of people to use it. That's how people get in touch with AI easily.
Yeah.
Before ChatGPT, there are many AI models created, but usually it's only people who are learning computer science, people
Mhm.
who are in huge companies that need it.
Mhm.
They're using it specifically for their work or task.
Mhm.
ChatGPT gives people a chance to use it in their daily life, which
Okay.
give us the opportunity to expand the usage.
Ashley, I want to ask you, have you used ChatGPT yourself? And if yes, what do you use it for? And how does it help you?
I am a proud member of the free users group of ChatGPT, but I actually use it for a couple of different things. I use it really more so from a not necessarily back-end administrative. I actually use it from making it a little, making the creative process a little bit easier. So what I'll end up doing is for the marketing and sales emails that I actually write, sometimes I'll actually take that text and put it into ChatGPT to make it a little bit more readable. I think that is one of the most exciting things because I know for myself as a medical professional, it's really easy for me to get very focused on the medical jargon. But a lot of times, and you probably notice this with your when you're speaking with your patients, Dr. Abbasi, is that we have to be able to translate that into something a little bit more digestible and more, we'll say, common person English. And so what I'll end up doing is I'll end up creating more of like a technical document. And then I'll say, ChatGPT, can you go ahead and transition this into someone who's never heard these words before? And I got an opportunity to experiment a little bit more because I think really a large part with all of this is it's the output is very dependent on the inputs that you're putting in, but then also based on the data that's being fed to the systems itself. Because we could teach these language models that up actually means down and down equals left. But if that's not technically true, then we end up getting a model or a program that actually ends up just behaving poorly because we gave it the wrong feedback mechanism. But I thought it was really cool because I got to experiment. I literally would say, okay, here's this 500 word text. Please convert it into something that is readable as if I'm trying to explain it to a Gen Zer. Right. So then that way it actually starts to borrow the terminology and explanations in regards to how you can communicate with them. And I thought it was very, very cool.
And that amazing part is that the model understands what you mean with, even you explain it to a 9-year-old person or explain it to a mechanical engineer and so on, that it understands what that means and what are words associated for that level for a 9-year-old versus a mechanical engineer explaining the same concept. So the concept, the model really works. Now, the result is not always consistent. If you ask the same question twice, you get different answers. But that is part of the intelligent. You remember, the intelligent is not going to a database and looking what the answer to that, but creating it as you go. And that is the creativity that we talked about. Every time you vary, you have this variation, you are creating a different version. And then eventually you learn which version works better or which version has the better result. This variation in mutation, in evolution, and here, this variation is what creates practically a variation and the selection that creates the improvement or the evolution, and we are watching it in a light speed now. Now, I want to talk about how, as medical profession, as medical professional, how can we use this? So first, obviously, Ashley, you told us about that you use it for make it communication with the patient easier. I want you guys talk about our current, because believe it or not, we have, this is my AI department here in the Inspired Spine. Why don't you guys explain how are we going to use in the next few weeks, in the next few months, in the next few years, how are we going to use our AI system? Practically, I'm asking you to give that talk that you give few weeks ago, both of you talk about what are we going to do with artificial intelligence?
So we have several projects for our artificial intelligence. The most important one for right now is an AI scribe. Like, are you familiar with a scribe is, right? So yeah, we're trying to have an AI to listen to the clinical conversation and produce a medical record with it. So this saves a lot of time and energy for everyone.
And I'm a proud user of that system, which we call Suri, in the last 2 days for evaluation purpose, and hopefully soon for real. What Suri stands for?
You named it.
Yes, smart. Smart utilization, Suri, smart utilization resource identifier.
Yeah, fancy name.
So, but practically what it uses that it's smart, and it uses utilize our resources to give us the solution we need in our clinical setting.
Yep.
So Project Suri that we have started, listen to the conversation that you have with the patient and create a medical record as you go, and it doesn't misses any conversation just because like our scribes, sometimes they'll get distracted and so on, they miss things. Suri doesn't miss a beat.
Yep. And other use cases include coding. Like we take the diagnosis from the medical record and we put a code to that, and that will help coding and billing. And also for prior auth purposes, like different payer have different policies regarding the authorization of certain procedures, and AI can understand what those procedures are and try to gather the corresponding supporting documents to authorize a procedure and to get paid. And what else? Oh, we have the audio assistant, basically call answering personnel, like an AI personnel to answer patient calls that are repetitive in nature. Like, I'm feeling pain. Is this normal? When can I take a shower? When is my refill, etc.
And it's about the research. Talk about our research project with the Suri.
So it's not with Suri, but our research project, we want to use some other AI models, like an SVM or anything to detect anomalies in the data.
So, and explain how is that different from the rest of the project?
Okay, so the one with the research is actually unsupervised learning. Are you familiar with supervised versus unsupervised learning? Ashley?
A little bit, but fill me and the audience in.
Yeah, a little bit. So the supervised learning is where you have a desired output, like ChatGPT or like most mainstream AI models. Like there is a correct answer. Does this patient have this is a disease? Yes or no. Like there is a correct answer. But for unsupervised learning, there is none. You have to have the computer or the model discover patterns on its own. So suppose we have one-dimensional data like patient height. Like you can see it's a bell-shaped curve, like people are like from 5 to like 6 feet, but suddenly you see a bunch of patients having 10 feet in their height. Then either we evolved or there's a mistake. And if you expand that data collection into a 2-dimensional data frame, then you have like a scatter plot, and you see people usually scattered around an area, but they're outliers. And as we increase dimensions, we can spot like why patients cluster in higher dimensional space. And there are important or interesting questions to ask in that regard.
Now, all of this for us is not theoretical. I want to have a demonstration here from our project Suri. And in that regard, I'm going to actually share my screen and show you the project Suri. So, Ashley, are you able to see our screen?
Yes, I can.
So, the project Suri, which we daily, twice a day, I have a new version of it, thanks to these people here, is start with, understanding when are you, where you are, and who you are, because it want to adjust to your situation. And then I go and going to go and go here and just say that test 1. Now, Misha, I like you to be the patient and I will be the doctor, and we are going to have a conversation about the thing, and we are going to simulate Project Suri right online for everybody. Now, this is not rehearsed. This is just very spontaneous. You see that he feels a little uncomfortable, but let's just try that.
Wait. What kind of problem do you want me to have today?
Doesn't matter. You just make something up.
Fish, no fish.
No fish.
No.
So we will do something that we do there.
Yeah, okay, all right, cool.
So I'm going to start recording. So hello there, I'm Dr. Abbasi. I see you have come here and my assistant telling me you have pain. Why don't you tell me with your words what your problem is?
I'm having pretty severe lower back pain because I fall off the stairs last week. I thought it's gonna go away, but it did not. And now I'm seeking doctor's help.
So tell me about that pain, 1 to 10, how bad is that pain?
It's like 8 to 10 in the morning and like 6 in the afternoon.
Can you show me where that is?
That's kind of like right here.
I see that you're pointing to the
Left
lower
side.
back,
Yep.
more left than the right. Does the pain go down to your legs?
Yes, it does.
Can you show me exactly where?
It's on the back of my thigh and it's kind of stopped at my knee.
And thank you for even saying that, because most of my patients just showing it to me, but I see you're pointing to the back of the thigh and a little to the side of the thigh, which I would call it L4 and L5. Does it go to your foot?
No, it does not.
Okay, now I'm going to examine you now.
Yeah, okay.
Now I'm checking now and I'm going to speak it loud for my system to understand me, but I see I'm examining you that you have 4 of 5 tibialis anterior weakness and 4 minus hamstring weakness. How long can you walk before your pain stops you?
I can walk about 20 minutes.
So you have a mild claudication with walking distance of 20 minutes. Now, what have you done so far for this pain?
I tried to go to a chiropractor yesterday.
Anything else?
No, not really. And I went to the doctor and they got an image and
I see that
still
image.
being painful.
Yeah, I see that image. I'm looking at the MRI of your lumbar spine that is done just 1 week ago. And I see that between the L4 and L5 on the left side, there is a part of the disc is pushing out. So practically your diagnosis is herniation of L4-5 with foraminal and lateral recess stenosis. And my recommendation for you at this time is do physical therapy. Obviously, nobody should get surgery if you haven't maximized non-surgical treatment. Racing can have some good impact on that. And if the pain persists, even injection, we should maximize all of that before we consider surgery. So at this point, I do not recommend surgery.
Okay.
Do you have any question for me?
Yeah, also just to let you know, I smoke and I drink alcohol. I smoke like 1 pack a day.
So
Is it useful for you?
well, when it comes to the surgery, that would be very important information.
Oh, okay.
that would influence your healing process and so on, especially smoking. Obviously, as a doctor, I always advise you to quit smoking.
Okay, I'll think about it. Thank you,
Okay.
Doc.
Well, thank you. Thank you for coming to us. So end recording. And now I'm going to, our Suri project is going to record this test. And it's now the first step. This is the program internal. This is not ChatGPT. We are internally have developed this. It's going through you tell us about the steps that this program is taking now.
So the first thing it does is that it generates a transcription of what was just spoken moments ago. This is the transcription.
Within few seconds, the transcription is already there.
Let's zoom in.
And that practically goes over everything that was conversed. It hears better than a human. It doesn't miss a beat. It doesn't really forget anything. It doesn't get distracted. That part is already significantly better than we have even a process that you can upload recorded conversation. And sometimes I have difficulty to understand on that recorded conversation what it is, but then this Suri still understand it very well and can go and literally. Now I'm going to take the second step. This is the second step. From the conversation that we had, and it puts important information and makes a medical record of that, that I can add my standard text if I need to. And then I can add, if I want to add additional things to that, I say, like, this is the synopsis of Dr. Abbasi, and we are dealing with the L4-5 left lateral recess disc herniation. And my recommendation is to maximize conservative therapy, especially physical therapy, before we consider any surgical solution. So I can add and complement this record. As you saw, it just appeared. And now I'm done with my medical record. And my medical record is already done. So, and this has practical application in our daily. It's already down there, I believe.
Yep, I think it's opening up.
Wow, that's amazing.
Yeah, and this is already being used. Yeah, I'm just going to stop sharing now. So this has obviously immediate use in our daily practice, and the medical record is up there, I believe. It's up there. So, and so for us, this is not theoretical anymore. This is actually daily use, and we are expanding on that and combining the doctors, medical professionals, and the people who understand the nature of that enable us to actually twice a day improve on our system. So I think we are at 6:30, so we are getting close to the end of our podcast. Thank you, everybody, but let's have some closing remarks.
Yeah, by the way, before we do that, Ashley, do you speak Gen Z language?
No, not really.
I happen to learn something like vibe check.
What's that?
What is that?
And then like checking vibe, like, are we
Oh,
okay?
vibe check. Okay.
Vibe check.
Okay.
Pop off.
What does that?
And it's like go ahead or something.
So what is that language?
Gen Z language.
What is it?
I don't know. It's
So pretty much millennials, which is anyone between actually right now between the ages of 26 and I think it's like 46, 47, like the oldest age groups in millennials right now are approaching maybe like their late 40s, early 50s. Gen Z is anyone under 26. So I think it's like from 26 years of age to I think about 11, I think, or something like that. It's like the folks who are growing up in this time.
yeah, I just learned some Gen Z language.
Okay. Oh,
excited to show off.
This is the practically a language each generation develops.
Yeah.
Okay, wow. Well, so any closing remarks? Let's go around.
Yeah, I'll start. So whatever the technology is and developing today, we all work together to make humans' life better or professional people's life easier. For example, we can have Dr. Abbasi focusing more on medical stuff instead of like word editing, just doing
Shouting
some
at scribes.
yeah,
Shouting at the
yeah,
stripes.
this kind of thing. So what we're working on is to make everyone's life easier.
Yeah.
That is what AI ultimately is used for.
Yeah, for me, I'm just like gonna make this product better.
Yeah.
It has a lot of room to improve, and I have other use cases to worry about. So
Do you enjoy every time you see every day it works a little better? Do you get a personal pleasure out of it?
oh yeah, all the time. It's a positive feedback loop.
Yeah. So Ashley, any closing remark? By the way, we are going to make our project available to the public very soon.
Exciting. I'm really excited for what you guys are building out there. I think there's a huge place and a huge benefit to AI. I think it's a tool that can either be used for good, but also could be used for bad. So I think it's important for us to be able to understand the power behind it and how it can help people, but then also understand that we got to be careful. But I think that there's a lot of huge opportunities, and especially in the healthcare space, when there's a lot of burnout, long wait times, and excessive spending. And I think the use of AI is going to be able to address those challenges.
And you just named it. It's a tool. Every tool can be used for good or bad. I assure you, we are going to use it for good. And one of the things that I hear a lot is, especially the providers, you and I, we want to take care of the patient, but the amount of the administrative stuff on our shoulder is, is tremendous. I'm hoping one day I can just concentrate on taking care of the patient, and that AI will help me to do that without getting out of my way, spending too much time in the administrative domain, and concentrating what I'm here to do, taking care of the patient. And we have made such a huge progress just in the last few months. So I'm proud of my team. Well, thank you very much for everybody who joined us. Thank you, Ashley, for joining us.
Thank you.
We are going to close our podcast for Essence. This is Dr. Abbasi. Thank you for joining us.
Thank you for coming.
Thank you.
Nice to meet you, man.
Thank you.
Thank you.
Bye-bye. Not working.
Oh, wow.
It doesn't let me close it.